emails or anything. Okay.
Busy with the
Yeah, that too. All right, so population. What are we talking about? When we talk about population, we are talking about all members in the group under consideration. And like I said yesterday, that could be just a small number. It could be the population of a country, right? So I don't want you to think, obviously in English, when we talk population, usually we're talking about population of a country or a large city or something like that. Population is everything under consideration for that particular event or idea that you're trying to find information about. Whereas a sample is a subset of that population, so a smaller number. And so our aim is to ensure, like I've said, that we are trying as best as we can to get our sample to represent that population, because sometimes finding information about the entire population, A, could be impossible. We talked about that yesterday about, gave you the example of a blood test, but also B, time consuming and costly. And so the idea is if we can select a sample or a series of samples that are representative of the population, that is what we would normally do. And that is the aim, to try and reduce bias in a sample and ensure that it's representative as best as we can as part of the population. All right, and so there's some examples there that you can read in terms of why. The blue whales came up yesterday, so that was pretty good. Why we would not use a population. I talked about blood tests, but something like batteries, light globes is another one. If you tested how long a battery would last for, if you did that for the entire population, you'd have no batteries left to sell. And so, those are some of the things that we need to think about. And so sometimes selecting a sample we're forced to select the sample. All right, so the sample helps us to make statements about the population. So the first example here just has get us thinking about whether we in fact need to use the whole population, whether it's practical. Should we use it? Should we not? Is it practical? Can we use the entire population? Have a go and we'll go through. Federal government wants to allocate some funding for those studying STEM and continuing on at university. Sample or population relevant here? Could we get the population easily enough?
No, probably.
Yeah, of course we can. Every school has to register all their students and the subjects that they're studying, as well as all the university preferences. So they will all get registered. And given that everything's online, it's quite easy to pull what people's first preferences might be and to pull the subjects that students are studying. And then from there, the data could be collated. That wouldn't be too time consuming, and so you could definitely use a population in that instance. What about the next one? We probably already talked about that. So that's obvious, sample. What about turtles in a lake? Would we use population? Would we find all the turtles in a lake necessarily? No, and depends how big the lake is. It's certainly not something that we would do. This is normally a sample, and we would often do something like this using that capture-recapture technique. You might remember that from your younger years. We will look at that a little bit later today.
So how would you, okay, this might be a little bit out of the course, but how would you actually determine a population of turtles from taking samples?
So you would do, so we use, yeah. So we use the capture-recapture technique. So the idea is you take a sample, you capture them, you tag them, send them all back, and then you recapture a second group, and then based on the proportion that you've tagged, will make you determine an approximate. It's never going to be exact, but it will give you a pretty good approximation as to how many turtles you might think are in the lake. Except there could be bias in those things, like you don't want to capture them all from the same spot necessarily, or certainly don't want to recapture them. They could be congregate. There could be areas in which they congregate. So you would need to pick, various areas to collect and then recollect. But yeah, we'll get through that in terms of how to calculate, but it is based on proportions, that particular one. What about the next one? Spending habits.
I think population.
Population these days, given that everything's online, population is particularly easy again to decipher. Now you guys might be a little bit young, but I certainly, with shopping, you've got your Flybuys if you go to Coles, you've got the Woolies rewards if you go to Woolies. So Flybuys sends me an email, a couple of emails a week, and then they say, oh, look at these specials. And those specials are based on what I buy. And so I buy, certain meat or certain products, certain fruit and veg, and they say, oh, look, grapes are on special today. You always buy grapes every week. Maybe that might entice you to buy some more, that kind of thing. So certainly shops like that, particularly if you belong to a rewards program, are always analysing all of their customers and the products that they buy to try and entice them to then buy more. So that would be easy enough. Only currently now, because lots of things are online, lots of things are in electronic. Obviously in the olden days, population probably not as practical. But of course, when we deal with a sample, it is generally quicker and easier and less cost. Quicker, easier, probably cheaper is probably the word I meant there, more than any other, than dealing with the whole population. And so as I keep harping on, because this is important with our sampling work, a well-chosen sample will give you good information about the population. And so that is what what we need to consider. How do we choose a good sample? So when we do that, before we actually start selecting samples, we need to think about the size. How big is it going to be? And I already talked about that yesterday. Can we remember what the numbers are? I think I've got it written here a little bit later anyway. We've got to select at least 30, or if it's a large population, square root of the population. But of course, we've got to ensure, or as best as we can, look at removing or eliminating or reducing bias. So we do need to think about, yesterday we did all those definitions about all the different sampling techniques that could be used. So we're going to focus on just a few, and the ones that are reducing bias. So we don't do much to do with convenience sampling because, self-selection, because that is full of bias. So we try and look at samples, and the idea behind samples is which reduce bias as much as possible. So as I mentioned, the sample does need to be large enough. Sample of 5, no, not good enough. Even 10, not enough. You can't say that when you're selecting 10 from a population of 10,000 that is representative of that number is representative of the population. Not enough. So we just need to make sure we talk about this idea of at least 30, and if it's a large population, the square root of n being the number in the population. So I keep harping on, as I mentioned, about minimal bias. So how do we select our sample? Well, these are some techniques we're going to think about, and a random sample is the most important idea. Make sure it's random. If you want to know about what's going on in a particular school, about a certain idea, I think I mentioned that yesterday, then we wouldn't select everyone from one year group unless we were targeting that particular year group. Or we wouldn't select it, if we wanted to know what students thought about maths, it wouldn't be good for me to select you guys, because you guys would just say it's all awesome, and we've got, Mrs. Kondo, who's absolutely brilliant. So we all love maths. But that would be a biased sample, of course. Get that grin off your face. All right, so here's an example. I'll give you some time to think about it. Is there bias? How can we minimise it? Yeah, they're only surveying people who are using the library, and if those people are using the library, then they're probably happy with what the library's offering. So it's not a good sample at all. It is completely biased. So how could we minimise the bias? What could we do? Yeah, hand it out to everyone. Send it to everyone.
Like mail.
So if we send to everyone, what are we expecting then? That could be a convenience survey, problem, self-selection, problem. People will not respond unless they are, feel passionately about something. Generally, that's when they would respond. So no, that's actually not a good way to find out information about whether we're catering for the library's catering for the needs of the residents. Give people.
Like after they do the survey, like a little.
Okay, so an incentive, perhaps that would be better if you've got an incentive to answer the survey, but still not good enough. What else could we do? Force people. Yeah, go to their door. Okay, if we went to their door and please, get them to answer the survey. What about all the time and money that would take to go to every resident in the town? Is there even a correct answer? Well, there is a good answer. What else could we do? Firstly, how could we get all the residents? Where would we get that information from? All the residents in the town. Government, the town hall, maybe the census data perhaps, or each town would have its own, or if like an electoral roll, for example, of all the people in the town. So we could perhaps call and get the information off an electoral roll. At least we'll get everyone from 18 onwards, but then we might miss the children. We could get households, all the household names in a particular town. We could get that information through some kind of government authority. That information is definitely out there through, through data, through rate payments of households. So we could then target certain households by randomly selecting them. How could we randomly select? So we wouldn't want to do this for everyone. We could go and knock on the door and ask, sit down and ask for times to sit down with someone in a particular household, but we wouldn't do that for all households. We need to randomly select so many households. Now, it does depend on how many people live in the town or how many households there are in the town. So if there were only 100, we'd need to do 30 if it was a really small town. If it was a large town, then we would need to do the square root of the population, whichever is bigger. We would randomly, give me an example of how we could randomly select households. We could do every second house. That still might be too many. We could have every so many. So we could work out how many people in the town and work out then how many every so many we would need. That could be an option. So that's an example of systematic sampling. What else could we do?
You could go through, you could pick a street, you say, okay, we'll do Smith Street, and then use a random number generator to generate a random house number, and that's your thing. And then do that like 3 times or something per street. 3 times. We'd have to do that for every street. We couldn't be biased because, people talk on streets. They talk to each other and they might have common, Smith Street, they might not be happy because they don't like, things that are going down in that particular, on that particular street. So we'd have to randomly select streets, we'd have to randomly select households. How could we do that? What if we had in one street 100 households, but then in another street only 10 households? What if you just look at a map and then throw a dart?
You could. Is that random? Let's go back to that. Go back to that information that the council will provide to say, right, these are all the households in the town. What could we do then? We could allocate them all a number and generate however many random numbers we might need. At least 30, could be more, depends on how many households are in the town. So the idea is just a random selection. So systematic would be okay, or just using a random number generator to select our sample. We want to alleviate bias. If we're thinking we want to at least select someone in every street, then we need to look at the households in each street and proportional. So that would be more of a stratified sampling. If there's 100 households in this street but only 5 in that one, then we need 20. We might choose 1 out of the 5, and then we need to choose 20 out of the 100 to keep the proportions the same. So yeah, lots of ways, but certainly bias, and we will try and minimise bias by selecting a random sample in some way. But we do need the data to know how many residents or how many households are in the town. All right, so we're talking about random sampling. Here's an idea. So the easiest type of sampling is just a simple random sample where everyone has an equal chance of being chosen. So if we took all the households and we allocated them a number, and everyone will have an even chance of being chosen. Let's say there were 999 households, we'd number them from 1 to 999, and then we might select whatever the square root of 999 is, however many that is, it'd be 30 something. And so that's basically what this is talking about. List of names, we give everyone a number. It's not just about people. If we're talking area, this is an example of looking at, how weeds are growing on a particular type of grass. I don't know, whatever that might be, and whether a certain pesticide or weed, whatever it is, herbicide, eliminates these types of weeds on that particular grass. Is it working? Is it not? Or different herbicides used for that particular type of grass? We would investigate by looking at areas. We wouldn't go counting all the weeds for, hectares of grass. And so, that's a particular example. And then we would randomly generate a certain area. However, let's say we had, 100 square metre lots of areas, then we might select however many we need based on the total land area. So, how we can use a random number generator? Well, we can use our ClassPad to generate random numbers. I'm not sure if you've done that before. It certainly hasn't come up much in previous courses. So we can go straight into main. And so one way, so the information provided on the screenshots shows you how to do that in stats, in stat mode. I'll just show you how to do it in main just to start with, and then you can go on and have a look at the stat mode. But the idea is we need to get RAND. And so if we arrow down, we need to go into the catalogue, go across. So just arrow across to our letters, go to R, and you'll see RAND there. Now, if you just tap RAND like that and then hit execute, it will give you a whole series of random numbers, and they are all between 0 and 1.
That's crazy. What's rand bin mean?
Rand bin is where you generate a random sample that follows a binomial distribution. Yeah, it's pretty cool actually.
And so rand normal bin?
Same. Yep, normal distribution. Okay, so this is all, so this is how we just generate just a random number between 0 and 1. If we want, and then that would be helpful if we needed to generate, so we could, it depends. We could be looking at the first digit, we could be looking at the first 2 digits, the first 3 digits, or we could use that as a multiplying factor to find a particular random number that we want in between 2 values. If we want integers, then RAND with the integers in question, let's say between 1 and 10. Oops. Let's say we were generating rolls on a 10-sided die, for example. Then RAND between 1 and 10, and if we keep hitting execute, we could pretend this was a 10-sided die, or, we could change that to RAND 1/6 if we wanted a 6-sided die. That gets a bit tedious after a while. You only do that if you need just a handful of numbers. What? Yeah.
I have a question. If you want to generate a number, say, between 1 and 5, would you want to include a certain number of decimal points?
Yes? So that's when you would go to RAND, generate your number, and then you would go times 5. Oh, you'd probably have to go 5 times RAND, I would suspect. And then that generates your random number somewhere between 0 and 5. If you want it between 1 and 5, you have to add 1. So that include that would be if you're including decimals. So yeah, it just depends. If you don't want decimals, if you want integers, they're much easier to use RAND. And in fact, RAND list, and this is where stat mode is pretty helpful. If you go RAND list, the first thing you need to put in is how many you want. So let's say I want to generate 20 random numbers. I put in 20 between 1 and 10. Then it's 1, 10. So this will give you your random integers, and there it is. It's a whole list. So it does the 20 all in one. And hence the reason why stat mode might be helpful, because you can see them vertically in a list. So you can play around with that for a bit. Yeah, RAND list. So the ones that we would use is RAND between 2 integers, or RAND list if you want to generate more than, a handful of numbers. And like I said, we could do that in stat mode. The list is helpful in stat mode. So going to stats, I just want to clear all my data here. And then if we go to the list and highlight that bottom bit where it says cal, and then type in there what we want. So now I've lost it. I've got to go back through my catalogue. So RAND list, and it would be.
How would they
So
know
I don't know
whether you used the random function or not? You could just write down numbers.
Correct. You could. So there it is there, and then from there we could calculate all the stats that we need as well.
The 7 I got 7, and the 10 I got 10.
So yeah, no, we don't actually know. So we don't. So we just take that on face value that that's what you've done. But you could essentially, yes, make up your own numbers. Although when you do that, you just think about how there could be an element of bias in there, because you think, oh, I'm not going to double that number, I'm not going to have 3 of that number, and then suddenly there could be some bias, because if you have a look, you'll notice that, even just in those few that are showing, 9's come up twice. Now, would you do that if you were doing your own list? Most likely not. I'm not saying. Maybe you would. I don't know. In the first 5. All right. So that's just playing around with random numbers, and now we're going to do an activity where we are going to use a random number generator to select 6 students from a class. So we're going to do this using 2 methods. Now, there is another method. So the first method we're going to do is assign a random number from the U01 distribution. Now, that means, what do you think that means? U01. Uniform distribution between 0 and 1. What do you think? How do you think we can get that? So notice some of you saw RAND bin and RAND normal.
Surely there's a RAND U.
Is there a RAND U?
RAND C, RAND point.
So I want you to think about it. What do you think RAND is? Random between 0 and 1.
So it would already be uniform.
Yep, and it would already be uniform. So that's how we would generate using RAND. So you need to select 6 students. So how are you going to do that? How are you going to select your 6? Are you going to select the 6 highest each student, so you're going to do 24, you're going to generate 24 random numbers. Are you going to select the 6 highest, the 6 lowest, or I don't know, that's probably the easiest of the two.
Okay.
And so we give everyone gets a random number, and you're going to say, right, I'm going to select the 6 highest random numbers that come up. They will be my 6 students, or the 6 lowest, or not if it's the uniform distribution, because it's generated uniformly. No. So if you're giving everyone a random number, and you're going to just select everyone, so each number has each student has an equal chance of getting any random number uniformly. And so then you say, right, so out of all those students, I'm going to select the ones with the 6 highest. They've already been allocated a random number, and then that's just one way of generating your sample of 6.
We're doing the 0-1 distribution because it's less likely to get double.
So 0.5514. Student 2, I'm going to go down. I've decided 0.4634. So 4 decimals should be enough to generate all different ones. Not necessarily. And remember, I think I've decided that I was going to do the highest. 6, doesn't matter. 0.7615 and so forth. And we'll be here. Doing it this way, no double ups. And that's the advantage of using RAND as opposed to RAND list. Because you've just got, if you really need to eliminate bias as best as possible, if you do get double ups, we just disregard it if necessary, if we need an individual figure. And so that's why here you've got no double ups, pretty much. 4 decimal places, the chances are a double up are very slim. If you had to do a longer list, you might go to 5 decimal places. And so then I've decided for my students, I'm picking the top 6. So, last question. So this time we might allocate each one. So this is method number 2, right? Each one a number. 4, 5, 6, 7, 8, 9, 10, 11, 12, etc.
That seems easier.
Yeah, easier. Definitely easier and quicker, obviously, because we can do a RAND list here. But what's the problem with this? Yeah, double up. So what do? We can't RAND list 1 to 24 because we're probably going to get double ups in that. Oh, no, we only actually need to generate 6 random numbers. Everyone's being listed. So we've got a couple of options here. What would they be? What would the options be? If we go RAND list, we want 6 numbers. It is much quicker between 1 and 24.
What if you just did like 10 numbers?
So if I do that, well, that's a bonus. There's no double ups. What if I got a double up? What could I do? Just keep doing it. Yeah, just keep doing it until you don't get a double up. Or if you're doing it individually, one number, then another, you just disregard the double up and then keep going until you get 6 that aren't double up. So that answers that part 3 to that question. Oh, I should have written those numbers down here. Anyway, doesn't matter. Same deal. So you can see there's 2 different methods of generating random numbers and then allocating, finding a list based on the random numbers.